Hello and welcome to today's Machine Design webcast. Our topic today is connector efficiencies for the new wave of industrial automation, sponsored by TTI and 3M. I'm Bob Vavra with Endeavor's Design and Engineering Group. Let's talk about how you can participate in our presentation today. If you have any technical difficulties during our session, simply type your question into the Ask a Question box and a member of our team will assist you. You can also click on the question mark Help button in the upper right corner of your screen. We also welcome your questions during our event today, and we'll get to as many of those as we can during the Q&A session that follows the main presentation, so feel free to send in your questions at any time. To do so, simply type your question into the Ask a Question box and click on the Send button. If you'd like a copy of this presentation, please click on the Event Resources on the side of your screen to download the presentation. Also be aware that today's session is being recorded and will be available on the Machine Design website within the next week. You'll be notified by email when the archive is available. So let's make our presenter for today. Stephen New is the 3M Electronic Materials Solutions Laboratory Manager in the U.S. He has more than 25 years of experience in the electronics industry with products and technologies such as multi-layer, flexible circuits, chip-scale packaging, high-speed cable assemblies, industrial connectors, and cable assemblies. He holds 15 patents, and his roles have included product development, process engineering, application engineering, and now laboratory management. So Stephen, welcome to our presentation, and we're looking forward to this information.
Thank you for the introduction. Welcome, everyone. Today we're going to discuss connector technologies and how they enable and shape the future for industrial automation systems and design. We'll be covering market trends first, and then we'll go over some basics of connector technologies, common customer concerns, and then review 3M's products. We'll spend most of our time at the end going through system application examples, as well as a case study. Going into industrial automation first, this is a fast-growing and constantly evolving market. Currently, the market size is over 180 billion and continuing to grow in the mid to high single digits. It faces multiple challenges and manufacturers are under pressure to deliver. Some of the key problems faced in this industry are improved efficiency, cost savings, data to improve decision making. Also, fewer emergency interruptions and new revenue opportunities by achieving faster time to market. Looking at semiconductor manufacturing equipment next. This industry saw tremendous 19% year-over-year growth in 2020 and is expecting to see 8.5% CAGR for 2019 through 2022. Growth is across all segments of the equipment market. When we are looking at semiconductor manufacturing equipment, applications for this technology spans the full value chain from front-end processes through to testing and handling. Vendors are adding more and more sensors into their equipment in an effort to improve fab uptime, wafer yield, and reduce the total cost of ownership. John Holt, Senior Director of Fab Applications at PDF Solutions, noted that equipment measurement types and equipment sensor numbers have grown with wafer size and complexity. In fact, as the size of the wafers has grown, the systems have become increasingly complex and the number of sensors has increased. For a 6-inch wafer, there's an average of 20 to 30 sensors in equipment. For a 12-inch wafer, this is 200 sensors, almost a 10x increase. For both of these markets, connectors are often not the first thought, but they are critical glue within these complex systems and often strongly influence the structure of the network. This video will give you a glimpse into the technology of the termination processes behind our products. The technology can help resolve many problems and challenges 3M sees in the industrial automation marketplace. just saw how simply and quickly the 3M mini clamp and link connectors are to terminate. The traditional method of making these connections is using crimping connectors. Using crimping connectors, you first need to strip the cable jacket with wire strippers, which creates cable jacket waste and could damage the wire. Then the cable is set into the contact and crimped with a special tool, during which quality could be inconsistent. Last, the cable is inserted into the housing, and this is repeated for every individual wire. Crimping connectors tend to be inexpensive, but time, reliability, and waste should be considerations. Hopefully, that gave you a basic understanding how 3M mini clamp and link connectors work. They can be used in any application where you are connecting 3 to 4 wires, but they can make the most impact in 2 types of applications. The first is in machines with a high density of sensors, semiconductor manufacturing equipment, and other precision production machines. The main reason is the small, compact size of the connectors and ability to reduce bulky wiring. The second is in the systems with wide distances between sensors, conveyor systems, automated warehouses, picking machines, and other general industrial automation lines. The driver here is that the 3M link connector can easily splice into existing lines. We'll discuss each of these in more detail later, as well as sharing how one of 3M's key customers was able to reduce their total system cost by 30%. Not only were their costs reduced, but they achieved a time savings of 80% on the connector assembly. This means they saved money and were able to deploy their system faster. In the spirit of continuous improvement, Anywire, a group company of Mitsubishi Electric, wanted to enhance its already successful Anywire ASLink solution. As background, the Anywire ASLink is a sensor-level network that connects controllers, displays, and sensors to guide preventative maintenance with sensing level monitoring. The current solution already gave customers improved productivity plus time and space savings. However, the team at Anywire identified features that could make the system even better for their customers. These were, first, the ability to use any general purpose cable, which also allowed customers to utilize existing cable. Second, the ability to transmit power and signals over 2 core cable. Third, having a topology-free solution so that the network design could be optimized. Customer could easily implement T-branching, multiple drops, star wiring, and tree wiring. 4, high noise immunity, and 5, ease of connecting and branching networks. Anywire was able to achieve all these goals and save time and money at the same time. The solution that they developed with 3M saved 30% of the overall system cost, 80% in connector assembly time, and 50% in connector component costs. One of the key challenges to achieve these results was finding the right connector, and for this they turned to the team at 3M. Together we developed a breakthrough eco-branch system using 3M link connectors. These connectors helped to address several goals with their simple and time-saving installation process and connector configurations. To understand why the 3M link connector was key to Anywire's improvements, we can look at the installation process. In this case, we're looking at the 2-piece detachable version of the connector. The connector can be put onto the end of a cable or in the middle of a cable by simply breaking off an end cover. As you can see, there is no wire stripping involved at all. Next, you squeeze this assembly together with a standard pair of pliers. This engages the IDC contacts and latches the connector body together. Finally, the connections are made. The ability to attach the connector in the middle of the cable makes T-tap and H-tap branching easy. Next, the team at Anywire was able to develop an eco-branch system using the 3M link connectors. This allowed current cabling to be used to reduce waste and also implement a serial network versus a parallel network, saving both cable material and reducing the overall number of connectors needed. The final outcome was that Anywire was able to achieve significant internal time and money savings and provide their customers with 5 key benefits mentioned initially, with these 3 being directly enabled by the 3M link connectors. Let's review key considerations that engineers face in today's industrial automation market. When designing a system, what factors should be taken into consideration? Cost is always the obvious answer. That's top of mind. However, there are many other factors that are equally, if not more so, important to consider. Looking first at time savings, the time it takes to install and commission a system can be crucial. Even a delay of a day can translate into a substantial amount of lost revenue opportunity. And on the flip side, being able to quickly repair a system can reduce costly downtime. Also important is the overall system design and optimizing the system for performance, cost, space, and upgradability if needed. Reliability is another key consideration. The overall quality of the connector plays a large role in reliability, but let's assume that a quality connector is a non-negotiable requirement. One good way to help maintain a reliable network is the ability to visually check the connection to see that the wires are seated properly and engaged. You also want to ensure that no reliability issues are being introduced during the installation of the connector by minimizing the potential for human errors and reducing the number of loose parts and waste if these could be concerns in the manufacturing environment. Finally, we can look at field installability. Field installability can mean faster maintenance and potentially better overall system maintenance if it is not as cumbersome. It can also mean that the connectors can utilize existing lines to add sensors and field networking lines. All these factors should be considered when choosing system components. Each situation will place differing levels of importance on each, but it's important to consider the total cost of ownership. Let's review some of 3M's product offerings before we get into some system and application examples. 3M's offerings are designed with time savings, reliability, and field installability in mind. The 3M mini clamp connectors are most often used to connect sensors and switches. They fit 28 to 20 gauge wires and support up to 32 volts and 3 amps. 3M link connectors provide branching and splicing for both new and existing network lines. These support 22 to 16 gauge wires up to 160 volts and 5 amps. Finally, we'll mention the 3M power clamp connectors that are also used in field networking systems. These connectors are compatible with 20 to 18 gauge wires and support up to 250 volts and 10 amps. Within each of the product families we just reviewed, there are several offerings to address a range of needs. The 3M mini clamp connectors have a standard wire mount plug and wire mount socket. There's also a board mount socket with options that fit up to 4 standard plugs. Newly released products include the 3M mini clamp common socket, which accepts 2 mini clamp plugs, allowing for power and signal splitting on the sensor line. Finally, the 3M water resistant boot provides IP67 protection for mini clamp connections. The 3M Link connector series includes a detachable 2-piece hermaphroditic connector. This means that you only need a single version for each side of the connection, not a separate plug and socket. For customers that want a more compact connector with less parts and do not need the ability to disconnect the lines, the 3M one-piece branch link connector is available in standard and IPX4 splash-proof versions. Finally, in this family, the 3M branch mini clamp link connector allows a mini clamp connector to be directly attached, making it easy to quickly add sensors to the main network line. Power clamp connector line includes wire mount plugs and sockets, board mount headers, and Y and H type branching connectors. It is important to understand the connector landscape and the options available when designing a system. The traditional connectors for these types of applications have been terminal blocks and crimp connectors. These connectors are very popular for 2 major reasons. They're inexpensive and have a broad portfolio range. 3M's connectors provide a comparative advantage in regards to required installation time, need for skilled labor, reliability by minimizing human errors and using an IDC connection style, and the ability to visually check the connection during operation. Let's look at some system diagrams to give a real-world examples of how these connectors are used and what problems they can address. Mentioned before that equipment with a high density of sensors, such as those used in semiconductor manufacturing equipment and other precision production machines, can benefit from the 3M connectors. The main reason for this is that they help reduce the amount of required wiring by moving from a parallel network to a simplified serial network. Without going into any details on the network layout differences, you can clearly see the simplicity and optimization of the network on the right, which is enabled by using the 3M link connectors to create branches versus running individual lines to each connector from the terminal block. Reduction of needed wiring and the smaller footprint of the individual connectors helps customers meet their space requirements, allows more sensors and capability to be added to the equipment, or a combination of both. Next, let's look at a system that has wide distances between sensors, such as a conveyor system, automated warehouses, picking machines, and other general industrial automation lines. In this case, space is not a concern. The system diagram illustrates a similar value in being able to deploy a serial network. However, the key driver for this use case is the ability to quickly and easily customize lines in the field. Often, customers may have a network line that is extremely long, and pre-planning exactly where every sensor needs to be placed along the line is difficult. Installation inevitably introduces variations into exact plans. With the 3M link connectors, the line can be laid and then branches or splices to sensors can be made on the line. This allows the layout to be optimized. The link connectors can also quickly tap into existing network lines if modifications need to be made. We mentioned the 3M mini clamp common socket, and these are a few examples of how it can be used. The main sensor or power line can be run to the connector, which then splits the signal so that it can be run to applications such as photoelectric sensors, an air cylinder with a switch, or even to cooling fans. And the 3M branch mini clamp connector allows a direct connection from the sensor wires to the network cable. With that bit of technical understanding, let's move to examples that you may see out in the field. First example is a very traditional process automation line. If you have this situation, the first question to ask is what sensors and switches are connected, or would they like to connect along the line? For example, there are places where pressure, temperature, position, or motion should be measured. If so, you'll want to add a sensor, which can easily be done using the 3M mini clamp connector, and a link connector if you want to connect the sensor directly to the main network line. The second question to ask is if there is the need to redesign or modify the existing network. Are there any places where the network lines need to be branched or extended? This can be done with either the 3M link or power clamp connectors, with the link having the advantage of being able to tap directly into the existing lines without cutting them. In this next example of a food production line, there's a mixing station which could introduce splashing or higher humidity into the connections. If this is near a point where a link connector is being used, then choose the 3M splash-proof one-piece branch link connector. This connector has a sealant for IPX4 protection and a cap to cover any exposed wire ends. In another step along the process, there may be a temperature sensor that needs to connect directly to the network line. The 3M branch mini clamp connector provides a simple solution to reduce the overall number of connectors needed by allowing the mini clamp connector to be directly plugged into the link connector. In this example, you may see photoelectric sensors on both sides of the conveyor that are tracking the product position. With sensors that can be combined into the same sensor line, the 3M mini clamp common socket can be used to avoid running long lines from both sensors. In pharmaceutical production or any other applications where there are wet operations, 3M water-resistant boot offers IP67 protection to the 3M mini clamp connectors. This is a good option because it allows this additional water protection to be put in place only where it is needed. The transparency of the boot and the mini clamp cover also allows you to visually check the connection during operation. This video shows the installation of the water-resistant boot. Moving to some non-industrial applications, the 3M mini clamp and link connect connectors have limited voltage and amperage. High voltage and amperage applications such as heavy-duty robotics are not ideal applications for these connectors. Additionally, unless the 3M water-resistant boot is being used to provide IP67 protection, these connectors should not be exposed to corrosive environmental contaminants. In conclusion, there are many connector options available today. The challenge is choosing the best one that will help you achieve your overall goals. 3M's offering helps to provide time savings, reliable, and field installable solutions to customers and industries with high precision equipment, such as semiconductor, manufacturing equipment, and those with sensors that are widely distributed, such as automated warehouses, can greatly benefit from these features. If you'd like to learn more, please contact your 3M rep. That concludes the presentations. So with that, let's open it up to any questions. Thank you for your time today.
Thanks, Stephen, for a great presentation. We'll be getting to our Q&A here in just a moment. If you've got a question, please type it into the Ask a Question box and hit the Send button. And also, please take a moment to complete the feedback form that'll be located at the bottom of your screen. So a number of questions have come in during the presentation, but Stephen, I wanted to start kind of with this one. What's the biggest challenge engineers are facing in the industrial automation market right now?
I think primarily it would be efficacy. It really comes down to, when you're developing or designing your piece of equipment, whatever it may be, you're trying to come up with the simplest solution possible to connecting all your components of your piece of equipment, and you try to keep it just as simple as possible. And advantage that we have here is you've got a lot of different options, connector options, to be able to be able to simplify that wiring within your machine, reduce the wiring, and then, as we saw, you can also have the added benefit of reducing the installation time, and all that combines to having the overall total cost benefit to connecting everything in your piece of equipment.
And keeping it simple today is so important because you've got a wide variety of experience and skill levels in your engineering team and in your operations team, and you want to try and keep it as intuitive for them as possible.
Right, exactly.
You talked about the industrial automation market at over $180 billion and growing. Where are we headed from here? What are we going to see in the next 5 years or so?
The overall market growth is expected to go up by about 7 to 10% per year. This certainly be different by market segment. Your semiconductor equipment and electronics assembly have the highest growth rate, and that's based on where the 5G market and electrical vehicle market is going. There's a lot of demand coming from that. Material handling is pretty stable. That's based on e-commerce and logistics automation, and then the general machinery, automotive related machines, they're certainly the largest segment in size with a growth rate of about 5 to 7%.
Yeah, and you talked about some of those key markets, semiconductor, electric vehicles. If we do see some sort of an infrastructure bill coming through, that's certainly going to impact the growth rate. But overall, what are some of the applications that you see adopting this kind of technology?
Well, the largest adoption rate right now, at least for the mini clamp connector, we're getting the largest adoption ratio in semiconductor and electronics assembly equipment, and because number one, those areas are growing pretty quick, and then mini clamp is really powerful in putting a lot of sensors in a small amount of space. For the link connector, largest adoption is in transportation applications, transportation such as conveyor systems for warehouse automation, and that's because you got these long conveyor systems and everything in these distribution centers, and link is really suitable to put sensors. You run that big trunk cable long lengths, and it's really suitable to put sensors alongside that cable bus, and being able to tap in using a T-tap method really anywhere you need to, and also being able to be very flexible. That going back to if you decide to change something in your system, you can easily link is very adaptable to being able to change change a system, tap in somewhere new, put in a new trunk somewhere. So.
Yeah, and along those lines, talk about a little bit about the product roadmap for this series. What are some of the opportunities that you see, and what are some of the problems that these products might help folks in some of these industries address?
Yeah, so roadmap, there's for like the existing mini clamp and link, we'll probably have some very customized modifications that will roll out, probably driven by, let's say, Anywire or somebody like that, that's got a big application for something new. So there may be some select new items coming, over the next couple of years. But the big item right now is we are rolling out, at least for it's a very similar to mini clamp, and it's a new product line called the 3M Mini Stack, and it's focused on interconnect or I should say IC chip manufacturing equipment, and what's driving that is wafer sizes are getting bigger. There's more and more the number of sensors going into these chip manufacturing or microprocessor type manufacturing equipment is growing exponentially. There's just so many more sensors going into them, and every one of these sensors needs to get wired, routed, and plugged somewhere into the machine control system. And so there's the number of space constraints is going up, and which means size is important. And so the mini stack is going to allow more connectors into smaller spaces, and that can reduce costs, it can reduce equipment size, and you can even take that all the way through to requiring less factory floor space as well. And these are expensive factory floor spaces, being there in clean rooms.
Very good. One question from our audience is: Are these connectors UL approved?
Yes, they are.
That's an important.
Yeah, they each will have they'll each have a UL rating for current voltage and temperature, and then 3M's also done additional testing. Not everybody is that concerned about UL globally, so 3M does other testing as well, and has I guess you'd call it the 3M rating for those as well, for current voltage and temperature.
In the case study that you cited, three of the considerations were time savings, reliability, and field instability. What's most important to the customer in your experience?
Well, yeah, I'd say reliability. In the end, you install, you want the piece of equipment to work. If it doesn't work, nothing else matters, right? So, so I think that goes beyond, without saying that, reliability is going to be the most important. Beyond that, the others, all three factors, they'll end up contributing to the overall applied cost of the product. Certainly, if you have a high reliability connector, there's less downtime, and so you don't have that cost from that repair cost or downtime cost. Field installability and time savings, those help with your initial cost, because you'll be saving time in the assembly process, and with simplified connection system, you'll directly save on material cost, and then, like I said, with reliability, you'll reduce your downtime and repair time. And then, of course, ease of installation, that's going to be a cost savings as well, as it just reduces the amount of time required to install the equipment.
Yeah, this seems like one of those products where this seems like one of those areas where you could have a a lot of different kinds of people being involved in this part of the process. You can get engineers, you can get various people, even people on your operations team can be able to help expand and develop these kinds of processes.
Yeah. Yes.
That's all the questions we have here for the moment. If we didn't get to your question during our presentation, we'll be getting back to you via email. So I want to thank Stephen for the presentation today, and on behalf of Machine Design, I want to thank TTI and 3M for sponsoring our event today. And of course, thanks to all of you for joining us. Have a great rest of your day and stay safe out there.